There is a recipe for success when it comes to policy-based routing. First, build your access lists. Don't go into the construction of your route map until you build your access lists, which have the conditions like, look for these IP addresses. And then we can reference them within a sequence of a route map. That is done by a match condition. A match says, look for this. And a lot of times we do a match IP address. Let me show you that. We would go into a sequence like route map, PBR map, permit, 10. 10 being the sequence number, PBR map being the case-sensitive name for our route map. We go into that sequence and then we say match IP address 10, which is going to match access list 10. So access list 10 might match the web server. We could just maybe even have a host IP address or something more creative. It's good to have that access list built first, and then we can go and build our sequences which have match conditions. And then we follow that up with the set command. Now a set command says, do this. And it's only going to do this if we have matched under a permit sequence in a route map. And what are we doing with policy-based routing? We're saying, I want to override the routing table. Now the routing table says this destination goes to this next hop router. And so what we do to override the routing table is we say, instead of going to that next hop router, go to this next hop IP address, which is generally referencing a next hop router. So we say next or set IP next hop, give it the IP address of the router, and in this case, we see that here. So our scenario says, look for the web service traffic. We do that with a match statement. And if you see that, then set the next hop to 192.0.2.2. And the default, the regular routed traffic is going to go through ISP1, which presumably is our primary ISP. Once you've built your route map, it's time to apply it. We apply it to the receiving interface. That's really important. So we apply it to the receiving interface by doing the command IP policy route map. And then we reference the case-sensitive route map that we have crafted. Now I want you to notice that there's no direction here. There's no direction. We just apply it to an interface. And so that means that we lack in the syntax to say that this is for receiving traffic because it is assumed. It is applied to received traffic ingress on that interface. Get that in your head. I've struggled with that myself. It's received traffic only, so we'd have to apply it right here. Now we can also apply traffic to the local policy. It's not really all that interesting, but just in case you need to control traffic generated by the router, there is a means of doing that with PBR. Now verification, the last step of the puzzle, is done with a few different commands. These commands need to be in your arsenal. Show IP policy displays where route maps are applied in terms of PBR. Show route map will show you the logic, but more importantly, the number of hits that you see in the route map. So if you have traffic that is PBR'd, show route map will show you how many packets have been policy-based routed. That's really important. Now, we may also want to debug this. You can get really granular, detailed information with debug IP policy. Traceroute allows you to see the next hop addresses, because what is traceroute? It allows you to see which devices you go through. And then ping allows you to control elements of the ICMP echo traffic in case that you have some parameters that are looking for it. For instance, you could control the type of service field with an extended ping. But make no mistake, traceroute is your friend when it comes to testing your PBR config.